Welcome to Rubber Duck Engineering. Tonight we're going to look at the programming language Zig, which neither of us have ever learned, but that's not stopped us before.
Zig is so hot right now, Eric. It's unbelievable.
Yeah, it's blown up.
I think this is Bun thing. I think there was this guy who decided Node.js was too slow.
Yeah.
And so he was gonna rewrite all of Node.js on like a 1-year bender. And he did it in Zig. And it came out like way faster. And now everyone is like, oh, Zig, that must be the reason why. It's like, no, I think it's because this guy spent a year optimizing performance. That's the reason that thing's fast. But it made everyone look at Zig for a little while. So we're jumping on the bandwagon.
Well, yeah, we're gonna join that hot second. Anyway, so we're gonna play with Zig, and nominally we're gonna try and implement SHA-3, but in our last minutes of prep, I think that it's probably outside of our reach tonight.
I think confidence zone, like pretty confident we're gonna get Hello World. SHA-3 maybe is like a North Star that we'll head towards.
Anyways, nice to see you, Dr. Barth.
Yeah, good to see you. How are you doing, Eric?
I'm good. Part of the reason why I know nothing about Zig is that I have been trapped under a vacation rock. I've been on vacation for the last month.
Good times.
Yeah. I came on a vacation very briefly to go to the Y Combinator alumni batch thing this last weekend.
Oh, I saw a photo on Twitter, like people like around the block for this thing.
Oh, yeah. It turns out running events is hard, like most things in the world. But, it was like thousands of people, thousands of founders. I did Y Combinator, 16 years ago. This is the first time I've been to a Y Combinator event in 16 years. And it was awesome. So,
it was just the same. It hadn't changed at all in 16 years.
Something like that.
Hey, James. Thanks for joining us.
Does James actually have a duck as their avatar?
I'm not sure. It's definitely yellow, like a rubber duck is yellow.
Anyways, standard disclaimers apply. We have no idea what we're doing. We don't know Zig. Please do not take this as canon.
Yes, please do not form any negative opinions about Zig based on us failing to use it for an hour, but we will try. That I think is, now you're talking C or C++. I'm not sure. I think import is how Zig includes things.
Yeah.
Oh, it's a fire daemon. Okay, right on.
All right. So I've jumped to the code machine because I had lost my screen share and added it back. So this is all I did was I installed Zig. It was quite easy. I installed Zig and I ran the Zig. They have some funny name for they're like Zig create. Zig init exe.
Oh, maybe you can init other things like a library or something.
Well, presumably. I mean, all the kids have fancy.
You gotta have like the multi-command tool that does all the things now. If you're cool. Oh yeah, you can make a lib or you can make an obj. I don't know what an obj is.
But it's interesting that they implemented this just as two single commands rather than arguments to the commands. Maybe whatever.
Well, it shows up in help that way. Like you don't have to go like the next level in help to figure out like what are the different things you can init. So I can sort of see that.
This is interesting. There's a build exe versus a build lib. Okay.
Just build. Yeah. Convert C code into SIG code. Oh, this is going to be our cheat code. We'll implement SHA-3 in C, and then we'll have Zig translated into Zig for us.
What?
Zig can be a C++ compiler? That's wild.
What does that even mean?
I have no idea. Okay. There's a lot to explore here.
Okay.
Can we try to build it just like building the default project and
build run?
Oh, that means build and run
it.
Okay.
And then it gives you this really ominous message, which for the very first time you run this, you're like, all your code bases belong to us. It was like, what did
my code bases? Including my Lisp interpreter? Stop. Yeah. I wanted to keep that one.
Are you telling I've been pwned by this random package I installed from the internet? And then it turns out that no, that's just their hello world.
Oh, I like this import syntax. So you like import a thing and then you shove it into a variable. And that's how you, like, instead of saying like import as, that's cute.
Yeah, it is cute.
I wonder if that's like first class. Like, I wonder if you could manipulate that, like put that in another variable or like pass it to a function or like do all that kind of stuff with it. I bet you can based on that syntax.
I wonder if you standard log info.
Yeah, what does that do?
I expect it doesn't take a variable. I expect that it takes a.
Well, we made like a.
Okay.
Oh, so you made like a formatter string or something. Like like Zig formatting strings.
But like, how do you do? Let's do const foo equals 1. Standard log. Help me, Copilot. Help me, Copilot.
I don't understand. What is this like dot
value
brace
of foo?
Oh, okay. Oh, that's like a context. I see. So the second argument is like, here's the stuff that you're going to pass in.
Okay.
Well, let's see if Copilot's right. This is a new way of learning programming languages. You ask Copilot in the comments how to do it.
Oh, I think that I read online this is totally a thing. Okay, that appears to work.
And now what about STD?
I hope you came here for the giggles and not for any amount of Zig knowledge.
But I think, did we talk about this in a previous episode about how this is like now a barrier to entry for new programming languages?
Oh. Yeah, the Copilot integration.
Yeah, because like it's super important, at least as we're going to do this, that Copilot knows Zig and could just do what you just did. Whereas if you just go invent YAPL, let's say last episode, then Copilot doesn't know YAPL from anything.
What are you saying about YAPL?
I'm saying YAPL is going to take over the world. It's slow. It's a slow burn, but it's going to get there.
It's a 10-year overnight success.
That's a 10-year. Aren't all overnight successes 10-year overnight success?
Maybe a 10-decade overnight success. Okay. Okay. So I have no idea what this dot does. Is this the like context operator or something?
I don't know. I mean, we could try to figure that out. This like C has this problem too, where just like the hello world in C uses printf, which is super complicated and has all this esoteric stuff in it that is not used anywhere else in the language. And so I don't know how much we want to dig into the logging system because it tends to have weird stuff in it.
Oh, that's fine. Okay, so to look at, let's talk about our hoped goal.
Okay.
So SHA-3 is a modern hashing algorithm. A hashing algorithm for, and probably everyone in the audience knows this, but I'm just going to say that so we're all in love with it, is a way of taking a generally larger pile of data and turning it into a smaller pile of data that is hopefully unique for that data. It's trying to reduce to a smaller set so you can say, then you have an identifier.
Yeah, you usually take a lot, like, a string, and you're going to reduce it down to a certain number of bits, like a fixed number of bits, like, I don't know, 256 bits or something.
And this is useful for all sorts of reasons, including verifying that the thing you were handed is the thing that you were supposed to be handed, because the hash matches. When you compute the hash, it matches the hash that you were given, because a good hashing algorithm shouldn't have collisions. It shouldn't be possible to generate a string that matches any specific given hash.
Yeah, so the idea is maybe it's easier for you to transmit 256 bytes in a careful way as opposed to many megabytes. And so you could transport the hash very carefully and then use it to verify the large amount of other data.
Yep. Anyway, so MD5 is a super popular one from like the 70s.
Oh, yeah. So basically, there isn't a good theory of hash functions in the cryptographic world or the cryptography world. And so people keep making hash functions and they keep getting broken. And so MD5 really broken. Do not ever use MD5. And then SHA is the secure hash function, which the larger the number is afterwards, the more likely that is to be true. But SHA-0 and SHA-1 are totally broken. I don't believe SHA-2 is broken, but SHA-3 is sort of the current recommended secure hash function.
Anyway, so the United States government and the National Institute of Standards and Technology picks these things.
They have like a bake-off. Like people submit all their ideas. Like, oh, I have a crazy idea for a hash function. What if you did this, that, and the other thing? And then every so often they have this big bake-off where they sort of narrow down the field and eventually anoint a winner. Be like, okay, you are now the secure hash function number 3.
Correct.
Maybe we got it this third time's the charm. Maybe we got it this time.
Well, and I don't know this because I've never worked in the government, but I suspect that there may be different ones that they use for the non-public versus the public.
Yeah. There's a whole suite of like, this is the cryptography that's used commercially, and there's a separate suite. I think actually 2 separate suites for, this is the ones used for like classified military stuff. This is all the public stuff.
Anyways, I looked at, I have been vaguely crypto adjacent in my career. I wrote an undergraduate honors thesis that happened to touch on crypto many moons ago. And I went to a crypto conference once, but I am anything far from an expert here. Anyways, I was doing research for this episode this afternoon, and I looked at doing like a block cipher sort of thing. And the modern block ciphers, where you like encrypt something and then be able to decrypt it, those were way more complicated. But this looked actually doable. There's some little bit of complicatedness, but it looked doable. Anyways, this is the official selection paper from 2014. I don't think there's a SHA-4. Maybe there's a SHA-4 process going on right now. Again, I'm not up on that.
Pato, hi. Thanks for joining us. Oh, I like your t-shirt.
Nice. And then we were going to explore Zig. We were going to try and use Zig to do this.
So is it like a spec? Like how do we get started implementing this?
For SHA, I think the best place, so there is a spec, and this doc has it, but this seemed like the most accessible spec.
Okay.
Literally the Wikipedia. It might not be right, but I suspect it would get us close.
Okay, so given an input bit string n, do a bunch of stuff. Okay. So yeah. Do we just like start at the beginning of this and try to do each step? Is that the idea?
I think if we literally copy pasted this in, we could talk our way through this. Uh-oh. Oh, like.
Oh, it got some like weird wiki formatting.
Copy LaTeX or yeah, something like that. Anyways, given an input string n, a padding function pad.
Okay.
A permutation function f.
Okay.
That operates on bits of block width b.
Okay.
At rate r. I think.
Are these like parameters that we're gonna have to know, like b and r?
Yeah. Well, I think so. The SHA, the smallest one we talked about. Let's do SHA-3. I think it's 244 is the smallest one.
So that's particular values for these numbers.
Yeah, so I think I think R is 244.
I see.
And then if I recall from reading the spec, the
that's what the Copilot just cracks me up.
I have no idea what it's doing there. I could be wrong.
That's okay. So, but we're supposed to start off just sort of generically based on these parameters.
Let's finish. So input string n. So this is the.
Okay, let me try to.
If I knew how to write pub fun SHA-3, I don't know how to do.
We should look up how to take
an argument.
An argument. Yes, that would be a good place to start.
We are so far over our skis. Let's see. How did we get here? We got here this afternoon because we were like, we've been talking about doing SHA since the very first episode and never gotten around to it.
Right. We were ideating what should the show be like. We were like, oh, we could like implement SHA. That would be a fun episode. And then here we are on like episode 100 and something.
And then I asked him, what language should we use? Expecting him to like pick Rust or Dart or JavaScript or whatever. And his response was, well, what one haven't we used? And I started listing back OCaml, Haskell, and then we arrived on Zig, which neither of us has ever touched.
Sponge. All right, this is cool.
The Sponge thing, I think, is just a fancy name. I think they all kind of do this. They have like an accumulator, basically. You take in the new amount of data, you generally XOR it with some sort of fixed thing. You permutate the bits, you swap them around, and then you permutate the bits, swap them around, XOR them with the existing state, and then that's your new state. That's how MD5 worked.
These numbers don't matter.
Okay, feature small, simple language, performance, and safety. Choose 2. Great. Show me how to do arguments. Argument, pass, argument, zig. Show me the money. You have parentheses. You must take arguments. This must be possible.
They have like Go has this great like go by examples.
Yeah, that's what I want. Okay, so it's name colon type.
Mel B is going to be stoked. She really, really wanted a zig SHA-1 for well over 20 years. Who is Mel B? Is Mel B like a prominent figure in the zig world? I know nothing about zig other than it's really hot right now and I should learn more about it.
There also is a zig SHA-3 implementation, at least Googling. Maybe it's not up to rubber duck engineering standards, but
it's not down to rubber duck engineering standards.
it's not the first zig program that they wrote. It was maybe the second. So how do we do a string?
Well, I'm trying to get like does zig have like slices or arrays? Okay, array.
The thing was U8.
Arrays. Here we go. Oh, vectors. Okay. Oh, a vector is just the thing you. Let's see. Okay.
String type zig.
Right. So I think this is how you make a vector, like this. As a slice. Let's do bytes. It's like U8.
Yep. U8.
There we go. And then we want to return something.
We want to return
like a certain number.
Looks like they do have a U128.
Oh, we need 128. Okay, but we want to return more than that, right? Like we should return a certain number of bytes, I would imagine.
I think the typical contract for these sorts of things is that you have a context object.
Okay.
Right, and then you call init, update, and like finish. Right, and finish you either could like pass in a buffer, or you could return an object. Like if they don't have a big int.
Okay, so maybe we should try to do that. How do we make an object in Zig?
Maybe we should have covered these basic things prior to this.
No, I think this is the fun of it. Like, here's struct. Okay.
Okay.
Here's how you make a struct. Okay.
Okay. What's with the dot?
Here we go. Here's an example. I'm going to copy and paste an example from the docs.
Okay.
So here's an example. So this looks good. So let's do hasher maybe. Okay. We don't know what our internal state is going to be. We're going to initialize it with something, void. Okay. Oh, I see. Oh, we have to return. We have to return our hasher. Okay.
Do they have like a constructor?
Let's turn these into use. I don't want any floats hanging around. Let's see. We get this, and then we want to add, right? Add information. We take a self. Okay, so this is, I'm starting to get what this is, right? We'll take the self, which is the hasher, and we want to take in some bytes, right? Okay. Bytes. And this is also, let's say void. I don't know, we have to be explicit about saying void. That we do. Okay. And then we want to finish. Okay. But then here, I'm not sure exactly what to write, but we can try writing this maybe.
So I have a proposal for you.
Yeah.
I don't know how you would test this work, but we could retarget not to SHA-3, but to our like own stupidest hash function, right? That implemented this contract.
Okay, that sounds good.
Because I think we'll have to cover a lot of the concepts like padding and we'll have to figure out how to XOR and things like that.
Okay, so should we keep some state? Like you want to just keep like a U128 as our state?
Yeah.
Okay. We're just getting the structure in place,
Yeah, exactly. We're building the structure so that we could imagine then writing something, because SHA-3 has a whole bunch of like funky permutations and stuff like that.
Okay, so we're going to like initialize our state to 42. Okay?
Sure.
And then we got a bunch of bytes.
Right.
And so
the Zig extension is implemented wrong in that it like forcibly pops open this window every time something is wrong.
Oh, that's super annoying. I want to like iterate through these bytes. Oh, 4 bytes in 4 bytes something state. Let's XOR. We do XOR equals. XOR equals the byte. Okay. And then finish. I just want to return like a vector that has a single byte in it, which is the state. I'm struggling now to figure out how to create a vector that contains a single object. I assume there's some
vector. What do you mean?
So I want to return an array of bytes, right? So I just want to return basically, like in Rust, I would write vec bang self.state, right? So I'm not sure. Maybe we say return a single byte vector containing hash. Okay, Copilot, you did it. Nailed it. This is actually a really fascinating way to learn a language, is to have Copilot teach it to you.
Whoa, that is not what I expected at all. Also, I never would have gotten there in a million years.
I mean, who knows if it's right? That's the problem with having Copilot teach you things.
So I mean, looking at the docs.
Okay. I mean, that's what they wrote there. That's pretty much exactly what they wrote, right?
Where?
On line 21 of the docs.
What is this? This is some like...
I think you put a number there. Like you could say like, you probably put the number 4 there. Like I bet we could put the number 1 here, and that would be legit. This ampersand I'm a little bit unsure about. I think maybe this converts the array into a slice.
Okay.
Well, let's try to use this, right? So let's go down here. So we want to make our hasher. So we say like var hasher equals hasher.init. Okay.
Yep.
Hasher add hello world.
Yep.
Const hash equals finish. Okay.
Yep.
And now I want to log it. Hash. The hash was.
If I wasn't so rushed this evening, I missed an opportunity to name this episode SHA-4.
SHA-4. That'll be next episode. This episode we'll do SHA-3. Next episode SHA-4. It'll be the greatest hash function known to man.
This could be our submission to the next NIST.
We're getting a jump on the next NIST competition.
Oh yeah. You know, whoever it was deployed Zig in order to take over the JavaScript world. We can deploy Zig to take over the cryptography world.
I think they actually require submission of implementations in multiple languages.
Oh, really?
Part of the bake-off, yeah.
Interesting.
Okay.
Oh my goodness.
So there's no squiggles? Like there's no like show me the error inside my editor.
I think that despite this having 30,000 installs, I don't think that this editor integration is to the level of the Rust one.
Okay, because that's a really thing about like modern IDE integrations, is they just like point you to the errors in your code. Is so super useful. But okay, we can do it this way.
What? Yeah.
This is part of why it's hard to make a new language, by the way, is because there's so much tooling that you need to do in order just to like to meet people's expectations.
The cost to just show up is just so. Yeah.
Did you want to clear it and then make another one?
I'm trying to figure out. I don't think you can clear a PowerShell terminal. I think you have to kill it.
Kill it. Okay. It's dead. It's dead, Jim.
Well, it's Windows, so it may not actually be dead.
It's a zombie, Jim. It's using your memory.
Okay, so that was our efficient clear process. Cannot assign to a constant.
Oh, okay, that's legit. So why is it a constant? So self. Trying to say like mut or something.
Hasher.
Oh. No. Okay, so we need to learn something more about how to do structs.
Objects.
Structs. We need to know more about like immutability. Like in Rust, we'd be missing the word mutt somewhere.
Maybe we're not really filling some fields. I see. Structs can have methods. But how did you define point in the first place?
Point seems fine.
Gives no guarantee with the order of fields. Okay.
Oh, var p point.
Yeah, but that's still referencing point up here.
Yeah.
It's weird that this like creates a type alias, and this then uses it.
Mm-hmm. Yeah, I think the const here refers to this. This name hash will always refer to this struct. At least that's what I would. Okay.
What does init?
So we think that the caret equals operator is a legit operator, but we think our problem is that we don't know how to make mutable fields in our structs.
I don't hold any of this as sound knowledge. Error cannot assign to a constant.
So let's simplify it, okay? Instead of doing this complicated thing, let's just try to assign self.state equals 7, okay?
Yep, amen.
And see if we get a similar error message.
All right. Different error message. Unused function parameter. Bytes.
Okay, that's true.
What if we do this?
What are you guys doing implementing SHA-3? That's a good question. Welcome to the show. I know you're a regular, but a good question of what are you guys doing is this. That's what we're doing. We know neither SHA-3 nor Zig, but we're going to figure it out.
Don't make me show the banner.
Don't make me show the banner. The next thing in language is having to add copilots. Yeah, totally. Like, I really don't know how to make a new programming language now without like round tripping with all these like AI tools.
Yeah, I mean, I think that
it depends how often they update them, right?
But we're also not done. Like Copilot is not the beginning. Like we already saw, others have come up with their own. Replit came up with one that does some slightly different things. Like we're not done. But you do think that some of these things end up being sort of services. Like I can't imagine that the team at GitHub, wants to maintain 300 languages.
Okay, so I found
how to make it unused.
Points. Yeah, we need to pass by. So we're passing by. The way we're taking self is making it constant, and so we need to pass. We're passing by value, and instead we need to pass by something else. Probably maybe.
Whoa, there's a Zig. There's a Zig format.
Oh, every language has got to have a formatter these days. Like after Go did it, everyone's got to do it. Okay, so the problem is the way that we're passing self. So we need to learn more about how parameters are passed.
I'm trying to see if I can get the darn thing to compile.
Okay.
Cannot assign to a constant. Okay, that's good. We passed. All right, sorry, I got to kill my PowerShell. There must be a way to clear a darn PowerShell.
So we need to pass self either by something else, like by reference maybe, or by instead of by value. But I haven't figured out. Okay.
Like you want like an ampersand self or something?
Yeah. We're sort of guessing at the syntax. We can ask Copilot what the syntax is. FN add. Here we go. It's a star. Copilot suggests a star.
Okay.
So let's try that. But I want caret instead of add because I'm weird.
For data. What? Whoa. Ooh. But we actually want it in slightly different sizes than this, but sure. Oh, I see. Our state is now U8. A very simple hasher here.
Yeah, okay. Could go easy.
We're just XORing the whole thing together.
Mm-hmm.
That makes sense.
This is a bit like Go, where Go you can take the.
Okay. Cannot format slice without a specifier.
Okay, what line is that? Oh, I cannot format slice without a specifier. We'll just take hash 0 here. Does that fix it? Whoa.
Whoa.
Whoa. The
hash is 39.
That's a number. Okay.
Okay. Okay.
So now we just need to make this a little bit more sophisticated to actually be SHA instead of XOR.
This is like the draw an owl, though.
Well, okay, but let's. But okay, but let's keep let's do the ears on the owl or something, right?
Let's see if implement SHA-3.
Oh, this is really cheating. Like, you're just saying.
Well, I wanted to see what it would do. But yes, that was cheating. I'm amused that this is what it came up with.
Those are not bad links. Somehow it knows these things.
All right. So, well, okay. So we could do a few things to this. So first of all, let's move to U. I think there's paths on our checking out here. Let's move to U128 here.
Okay.
And then.
So I'm reading the spec here, right? There's a state S to a string of B. So the state S is a string of B 0 bits. Okay, so we're basically setting B equal to 128. Assume B is 128.
Sure.
Okay. Mm-hmm. We want to initialize to 0.
Yep. Correct.
Absorb the input into the state. For each block, so would n consecutive R bits. Okay, so we gotta write out all these parameters, right? So
so R is less than B. I believe it's typically half.
Okay.
When I was reading one of these.
Blocks of it at a rate R and an output length D. We have a capacity C equals B minus R and the sponge something. Okay. I feel like we need a new intermediate step.
Yeah, that's where I was going. Is it?
Yes, Copilot just told us to RTFM. That's exactly what Copilot did.
So yeah, so this is where I was getting to a new intermediate. So I think we need to move to a larger state.
Okay.
And I think that two things that it does. So there's both. One of the things that the sponge thing inside the SHA-3 is that it pads the intermediate. So it will like read in, say we were doing this at 128, it will take 64-bit chunks at a time.
Okay.
It will take 64 bits plus 64 of zeros. And then
R, so we want, just for simplicity, we're going to say R at 64.
Mm-hmm.
Okay.
I don't know what the capacity.
So what is the pad function? So there's some mysterious function called pad that takes length n, yielding a padded bit string p with a length divisible by r. Okay, so let's write a function pad.
Here it explains it. To ensure the message can be evenly divided into r-bit blocks. Yeah, this is just the padding at the end. Right, every hash function has this.
Okay.
Because you're like, say you have a 128-bit hash, that doesn't mean that you like always end on exactly that boundary, and so you need to pad out zeros or something at the end.
We need like a block, right? Which is a struct.
SHA-3 uses the pattern 10 to the 1. No, 10 times 1? What? Oh, clean star. I don't know what a clean star is. Okay. A 1 bit followed by 0 or more 0 bits maximum, and then a final 1 bit.
Oh, this is the padding function. Okay, let's try to implement the padding function.
Maximum of r minus 1 0 bits occurs when the last.
It's got to be some fancy function such that you can't, you can't supply an input that whose padding equals another input padded. So it has to be a little bit tricky, right? Okay, uses the pattern. What is the pattern? 1 star 10 star 1.
All right, so it looks like it figures out how many bits it needs, and then it adds a 1, and then some intermediate zeros, and then a 1.
Okay, at the end or at the beginning?
At the end.
Okay.
Right.
So the 1 bit will be added even if the length is already divisible by r. Right? That's important, right? Okay. Okay, so let's try to write that function. That seems like an important piece of what we're doing. Yeah, this makes sense. And the 0, it could be 0 or more 0 bits, and finally a 1 bit. So you always add at least 2 bits, and then you add a bunch of zeros in between. That makes sense.
Okay. Yeah. So if it is 2 bits less than divisible by r, then it just adds 2 1s.
Okay.
Is my read of this. But we're doing 128 for our sanity's sake. So one danger in this is that we will end up implementing something that nobody else implements. I don't know if there's a SHA-3 128.
Okay, should we find like real values of these parameters for like a real SHA to start working with?
SHA-3 128. Let's just see.
Oh, here it is. Let's do SHA-256 just for simplicity. Right, so it has an R of 1088. So R is 1088. I'm just reading in instances in the Wikipedia page. Scroll on the instances.
Oh.
Your D is 256.
Instances. Right. Output size, yeah.
Let's do SHA-256.
That's wild. So they divided into 1088-bit chunks. Why?
I don't know. Why not? So what is?
Okay.
It probably has to do with like what's efficient to implement in hardware.
Mm.
I'm just copying this down into our account here. So D is 256. R is that. Capacity is 512. And then we need to compute D. No, what was the number we needed? B. We need B.
Yeah, B.
So, but B, there's an equation here in Wikipedia that says C is equal to B minus R. Okay, so we don't have B yet.
C is equal to B minus R. Well, that means that B is equal to.
Right, so C is this. Right, so 256 is equal to B minus R. So B, that's it. Yeah, that checks out. Okay. Okay. So we decided that the block needs to have. So how big is the block? N consecutive R-bit pieces. So R is this.
State is B, is width B.
The state is width B. Okay. So the state is. So what's this divided by 8? These are in bits, right? So we need 200 bytes of state. Okay.
Nicely divisible.
Okay,
so
200 bytes of state. And how big is our block now? Our block is R. And R is 188 divided by 8 is, so we need 136 bytes of state. Okay, so far so good. I'm just going to notate this down. It's 200 bytes Okay. Now we need our pad function, which is going to take in some number of bytes and output some number of blocks. And this was just Copilot filled in junk, but
okay.
I don't know. I got to delete that chunk. We'll try to figure it out. Okay.
Well, I was actually reading that because I.
Oh, okay. Let me comment it out so we can read it, but not
be
distracted by it.
It may teach us like how to allocate these. Okay. Interesting.
Right. So I think this is going to be useful. We need to figure out how many blocks we want.
We're going to actually end up byte aligned, which is nice, right? Because we're consuming.
Yeah, I think they select all these parameters so that it ends up like sane byte alignment. Like
I'm sure I just was when we start, in like 1088, I started getting worried.
Yeah.
All right. So So pad.
So step one, we need to like compute the number of blocks.
But this is not actually pad. You only ever execute on. So as this is defined, pad only ever executes on finish.
Oh, that's a good point. So if somebody passes in, we need to like keep as state the partial, like the unfinished block that we have so far, right? So we need another piece of state, which is like partial, like unconsumed.
Yeah, pending. It's like next block or pending block is fine. Yeah.
It's actually it's bytes, right? Because it's not going to be a whole block.
Sure, or it could be a mutable block, but yeah.
So we need another function that's first of all just like we take in a slice, and we get out the full blocks and the partial, right?
Well, so in order to do add, like add is going to do the part of the algorithm. If
there's like an add block. Sorry, what's the right syntax? Is it are we in snake case?
What, I'm sorry?
I'm trying to figure out what the are we supposed to? No, we're supposed to be in weak camel case.
Oh, you mean the style?
The style.
I'm sure Zig FMT would tell us.
I'm detecting camels with weak heads. So like
at least one source file argument. Whoa! Zig is mad at us.
It's okay. So here's add block, right? So we need to basically chunk out this data into blocks. So what did we decide? A block was.
Well, we take in the data,
yep,
and we add it to. We take the data and we pull bytes off it enough to complete our current block. If we ever complete a block, we then process that block, and then we while until we're at the end of the data.
Yes.
So let me try writing that pseudocode. It'd be like while data not is not empty. We pull off. We need to do needed is equal to it. And is this helping, or am I?
I'm just going to make a constant, like what? So I was going to make a constant for bytes per block, right? Which is going to be 200 and something. Okay, and then we know that pending is going to be less than. So I was going to say if self.pending, right?
I'm saying.
I'm trying to write the constructor for block.
Okay.
But what I want to do is I want to take in a slice here. If you look at line 22.
Sorry, I gotta make Zig not hate us. It does not like your.
Okay. What I really want to do is I want to return 2 things if I can. If it'll let me. From this initializer, right? I don't know if this is the correct syntax for returning a pair, but I want to take in a bunch of data. I want to get back a block and then the remaining data. Maybe I want to hit like an input manager. Maybe that'll be an easier way to think about this. Input manager has my.
I see, and you just dump the you just dump the new input into the input manager.
Right, and then you pull.
And then you say you ask it next block.
Correct.
So and if it gives you one, great. Right. It's while next block, process the block.
Add data.
Yep.
Add data, which takes bytes. Okay, we'll implement that later to do.
Yep. So it's then got add.
Okay, next block.
Data. Wow.
We haven't solved the problem. We've just pushed the abstraction level, but that's okay.
Oh. I don't know how you. So it's swimming blind here. All right. The Zig extension is like, no, you are not allowed to do work until you solve your problems. It does not like.
I want like an empty slice.
It doesn't like returning 2 types here.
Okay, take get rid of that. We don't need that. It was a dream.
Let me see if it lets us. All right, we'll see. We'll put it away and it'll come back if it gets mad. Okay, where are we? Well, our next block, and we're gonna do. Block.
Is it like an option or like a Zig? Maybe Zig, maybe return object.
Whoa, it has an undefined type.
I'm searching for like option or whatever. Like.
Just 4 string character index. Interesting. Function. Okay. Defer.
Looks like optional is question mark.
Oh.
It's going to return a question mark block. Now it's always going to return null. Okay.
Error expected semicolon found. Const input manager. Oh, this is equals.
Block. It's going to be a self.process block. Okay.
Interesting. The idea that Zig supposedly will transliterate from C. That must really constrain their available, like the language, what they can do in the language.
I think it'd be a fun thing to look at. Is like to try transliterating some C. But does this compile what we have now?
No.
Okay, what is the compilation error?
Expected semicolon found const.
Okay.
It never got a semicolon.
It was mad where? Which line? Line 52?
On 52, which presumably is this.
So we need a semicolon here probably?
Maybe?
Yep. Yeah. We're team structs end with semicolons.
Oh, okay. Sure.
This was, by the way, if you wanted to, the argument about whether in Fiddle, which is the future interface definition language, when you define a struct, whether you should have to type a semicolon after the struct, was the longest epic centithread in all of future development history. And I forget even which way it turned out, and it really does not matter at all.
I'm wondering about while.
Okay. Is while our problem?
Well, I mean, I wrote this fantasy code here of while, I'm assigning,
Oh, but does it compile? I just asked the compiler. Is that where our compilation error is? I wouldn't worry about it until the compiler complains about it.
Yes, error, expected expression found var.
Oh, okay. Okay. Sig while optional.
What is this? While with a continue expression. What's a continue expression?
I don't know.
Oh, is that
while with optionals is what we want to know about, which is in the documentation. So the way you do it is, it's this it has this funny binding thing. So you do it like this apparently.
Okay.
While this thing is a thing, bind it to this variable.
Okay.
It's kind of a weird syntax, but they have else. They have while and else. They're a while else language.
But did you see this? That it has a while with a continue expression. This I assume is kind of like a for.
Yeah, it looks like they jammed for into there.
How is this different from for? It doesn't have an initializer.
For has 3 slots, right? Initialize, test, and continue. So
this is like the 2, but why?
I don't know. It's a super weird choice.
I'm not trying to harsh their mellow here. I just interesting. For
looks like it's iteration.
They don't have the indexed version of for.
No, they did. That was the last one you highlighted. It can create 2 bindings, both a binding for the thing and a binding for the index.
Yeah, but they don't have the 3 input for, right? This.
Oh yeah, but that's very modern, right? It's very modern to want to use iterators instead of wanting to int I equals 3.
But this is the 3 input for right here.
Correct.
It's interesting. They just call it while in capital.
Capital. That's even a more clever thing than fiddle. We require the semicolon, which led to lots of fun when I forgot that rule. There was no error reporting in that case. It just hung.
Yes.
Yeah, we invested an absurd amount of work in getting nice errors for the IDL parsing errors, because ain't nobody knows how your IDL is supposed to parse. Okay, so does this run?
I just ran format on it. I have no idea if that. Let's see what big build does.
Okay.
Exit code 1.
The squiggles would really be a huge productivity boost. Oh, pad.
Unused function parameter. There were rants on Reddit about this.
Do we do this? Do we supposed to put an underscore in front of it? Is that how?
No, I tried that. Let's try it, but it got mad at me for it. No, you have to turn the whole thing into an underscore.
Oh. Okay.
You don't get a partial name.
Okay. Good to know.
Where's bytes?
For all these? Okay. Self-bound input.
I could be wrong. I did see rants on Reddit when you all have seen my screen the entire time, so you have all the information I do. Are we sad about block now? Okay, Zig build. Yes.
This is totally not right. So we learned how to do this. Yes. There you go. I don't know.
I mean, it looks plausible. It also looks like magic. It's like
there was another way of doing it.
Yeah.
Initialize state to 0. Okay. Well, that's what it wanted. There was another way of doing it where you could say 0.
I kind of get what this is. It's like, oh, this is a variable length slice, and it's variable because it's got the underbar, and oh, it's of type U8, and oh, this is the whoops. This is its constants. And then instead of being star, I'm going to be star star. I don't know why. Because I want to actually expand it out to be that size.
I mean, I found examples in the Ziglang documentation about this. So here is the canonical example from the documentation. So it looks legit.
Yeah, I'm not doubting it. I'm just it's a little
wild.
A little wild, yeah. Okay, we're showing our wild side tonight. Missing field input.
We didn't initialize this. That's fine. Okay.
Maybe there is a different Zig extension with squiggles.
We need to take self here, otherwise known as underbar. Okay. I do like this modern trend where you have to explicitly pass the self. Yeah.
Well, yeah. Yeah.
Okay.
Oh, why is it sad life?
I think I fixed it, so we can try just running it again.
All right, I'm gonna delete our shell. There must be a better way.
I feel like we're spending tons of time just trying to get the error message out of the compiler and correlate it with the source code. Like that's
exit global cache.
Can you scroll up, or is there more?
Oh, okay. Undeclared identifier input. Yeah.
Input. Oh, it's input manager, not input. Yep.
Okay. Sold. Okay. Get neck block. Yeah. I don't think the current Zig setup is compatible with our programming style of write a whole bunch of checks.
Sure. Maybe like a okay. Okay.
Where'd you go? Okay. Okay.
You just think that we've developed this programming style because we're used to Dart and Rust and have the squiggles that we can just go like click through the squiggles and like bang them out.
Yep. I think this has two. It's so interesting. I remember when in the very early days of Flutter, we made a conscious decision to print times of things in milliseconds instead of seconds.
Just to like emphasize the fact that it should be fast.
It turns out that some of these toothbrush journeys, like fixing an error, actually matter how many milliseconds they are. Expected type U8 found.
I fixed that one.
Oh, okay.
Now I'm trying to figure out how to make an empty slice.
Use function parameter self in finish. Okay, fine. We're just going to remove the finish function.
Yeah, we don't need to finish it.
I see. So, like, what do you do if you don't use self? You do that?
Yeah.
But then how does it know that it's the magical self?
I don't know. Maybe because it has the type.
Expected type star found.
Let's get rid of finish for now. Like we'll make a real finish when it's time to add a real finish.
Okay.
We do finish.
Oh, we're also at time anyways. So I think we should plow through this compile error and then gather the wagons.
No, we can't. That's fine. We'll just initialize and add. That's cool. Okay. We need to figure out how to make an empty slice.
Use of undeclared hash. Okay, fine. We realize we've broken the world.
Okay, I assume we just do it like that. Okay, we can do that. So I think we just need to do this like that.
All right. U8 found void. Oh, this is your pending. That's the thing you're fixing right now.
Yeah, U8. We're trying to make an empty slice.
some of the errors it shows, but I think it like is on a timer. Okay, it built.
We did it. We implemented SHA-3. Not quite, but we're making progress.
I think we're making progress. The other thing I would say to go back, I think we can close the code machine. I think this actually has sort of the seeds of a real project that I could get excited about. I like the idea of learning a new language.
I feel like you want to set the dials. Like you either want to have like, we're going to build a crazy new kind of program that we don't know how to do, or we're going to build a program that we like would be really easy to do in a language that we knew well, like this thing, but we're going to do it in a language that we don't know because we want to explore the language. And so SHA, I feel like, is a pretty self-contained thing. Like,
sure.
Like if I were to do it in Python, I would could do it.
It's going to have some squirrely bits. Like I think the permute function is just going to feel like magic, and getting that magic typed in correctly is going to be. But it's definitely doable. It is well within our like. I saw you busting out the input managers. Like, okay, yeah, you and I have written about 8 input managers together.
But it took a few minutes to like lock into the pattern. It's like, oh, I have this partial thing, and I'm getting more things, and and it was like, then the gears clicked. I was like, oh, input manager, I know that pattern.
Yeah, it's also like a in Dart you could use streams, right? You want it's like a chunked stream or whatever. So, final thoughts?
This is fun. I think I'm interested to explore more about Zig. It's making some sort of unconventional choices, which I'm finding interesting.
I want to see if I can find a slightly better setup for Zig, because it's going to drive me bonkers that we don't have squiggles and that the editor thing pops up. And
yeah, that's a good point.
I think figuring out how to get a slightly better Zig editor setup is going to be crucial. I can see what I can do before next week. So, anyways, good to see you as always. And
thanks everyone who came by and
commented. Thanks for hanging out, folks.
See you next week.